This video is an introduction to the study of integers. If you're in the Applied Algebra course, if you're following that, this is lesson 1-1, the very first lesson, because the first module is a study of integers. It's really a review because at this point in your math education you've probably already been through integers, but it's worth reviewing because most mistakes in math are made with the things that you've already learned in the past. Sometimes we get in a hurry, sometimes we get careless, but we make mistakes with these things. But there's a lot of misconception and a lot of mistake making that comes into play when you start dealing with positives and negatives in their interaction. There's a lot of rules to remember, and students can get those confused, so we're going to review that. But to kind of get you to where we're at now, I want to go back a little bit and review just the progression of how we learn number, how number enters our lives, and how we study it starting from the very beginning. So I put up the number sets. It's not really important that you remember that you know the number sets necessarily, but I think it's good that you've seen it and you know where you're at in the progression and where you're going from this point forward. So we're going to just review quickly number sets, and there are two big number sets that we study in math. One is the real number set and the other is imaginary. We're going to spend all of our time for the next several months in the real number set if you're taking the Applied Algebra 1 course. Imaginaries will come later. Imaginaries are characterized by the lowercase italics I. Maybe you've seen that. It represents numbers that really don't exist in the real plane, which is where we're going to spend all our time. So for now, we can forget about imaginary numbers. All of our work will be in the real numbers for now. Now, under the real numbers, there are two larger sets. There's the more common set to study, the rational numbers, and then there are the irrational numbers, irrational, which are kind of crazy numbers. They kind of follow their name. Square root of 2 is an example of irrational. If you put that in your calculator, you're going to get a decimal number that goes on and on and on. Pi is the best example, the most common known irrational number, and the most commonly used irrational number. And pi, of course, is a decimal that goes on and on and on and on. You probably have already seen this represented somewhere, maybe on a poster in the classroom wall. You've seen how pi just goes on and on. So they're irrational. They're kind of crazy. So when we deal with the irrational numbers, we will typically round. And you've probably I'm sure you've already worked with pi, and we round pi to 3.14 as a good estimation. And as far as what the types of measurements we need to take in the real world and the accuracy we need, that's usually does the job for us. So we round irrational numbers. However, in irrational numbers, although they're kind of crazy acting, they actually occur more in real calculation than real numbers do, than rational numbers. So why do we study using mostly rational numbers? Because rational numbers are easier to understand, and we need to understand math and how it works using simple scenarios. Then we'll bring in irrational situations that aren't as simple when we really understand what's going on. Makes it easier to deal with the crazy stuff. Now, quickly to go through the rational number sets. All math starts with counting. From the time you were a toddler, I have a grandson who's almost a year and a half old. We're counting with him. We count things 1, 2, 3. We don't go above 5 yet usually, but we start off by counting 1, 2, and these are the numbers you count with 1, 2, 3, and on up to infinity. You do not count with 0. 0 comes in as a different number sets with the whole numbers. The whole numbers are the same as the counting numbers, adding 0. Because eventually we need, when we first count, we don't need 0 because you don't count nothing. There's nothing there to count. You count starting at 1. But eventually we need 0 as a placeholder or to identify the absence of value. So early on in the primary grades, I think it's in kindergarten, maybe first grade, you get introduced to the number 0, and that's actually kind of a complex thing for a young student to understand. And then, so most of your elementary years are spent right here, the counting and the whole, but actually you do also get into decimals and fractions in elementary, but you don't really get into the integers or the negative counterparts of these. The integers is where we're spending our time for a while here, are all these numbers plus their negative counterparts. Well, in the progression of math learning and our need for math, we get to a place where we need negatives to describe numbers. We already have positives, but we need negatives to describe a number. The best The best example I can come up with, I'm going to erase irrationals for now, is let's just look at the numbers 25 and negative 25. Okay, 25 and negative 25 are both 25, and I'm going to talk about dollars. So $25 earned, $25 paid. In both instances, we're talking about the same $25. $25 has the same value in both instances. 25 is 25. But earned is a positive to us. It's added to our wallet. It's added to our bank account. Paid is a negative. It's going out. There's opposite direction or opposite action there, and that we're losing that money. Still, $25 is $25. So we need the negatives here or the positives, the integers, to be able to describe what's happening. It adds some context. So then enter the integers, and from that point on, we're always using integers. So from this point on in your math career, you're always going to have to deal with the interplay of positive and negative numbers. And again, there's a lot of mistake making that happens here, so we'll spend a fair amount of time practicing how those things exchange. Hopefully by the end of your practice and study of the integers, you'll understand how they interact with each other, and it becomes really more like muscle memory. The practice I'm just going to tell you can get kind of boring and repetitive. If you're taking the Applied Algebra 1, it's designed that way on purpose. We want you to practice to the point that you just know it. It's like muscle memory, and you don't really have to think about how the numbers interact anymore. You just know, you see it, you know what to do. But in order to get there, it takes a little bit of repetitive practice, which I understand can be a little bit tedious, but I would ask you just to persevere and continue to work hard, because I promise you it will pay off in fewer mistakes. So a lot of time here. We will enter in decimals and fractions with negative numbers. Negative numbers don't just come into play with the integers. They come into play also with decimals and fractions, which everybody's fine with decimals. Everybody hates fractions. We're going to review those things through a lot of the practice here, and hopefully you'll get better at both of them.